And so here we have x equals 3 sine t plus 3 y equals 2 cosine t. Remember what I taught you to do here is to um, get, get sine and cosine by itself. And so what we do here is we have x minus 3 divided by 3 equal to sine of t. And then here we have y equals cosine of t. And then we use this sine squared t plus cosine squared t equals 1. You just plug this in. And so I'll have x minus 3 over 3 equals to 1. And then if I crunch this through, you get like x minus 3 squared over 9 plus. And this is just an ellipse that's been shifted to with a 1 and 3 axis that's been shifted by a negative sign. The other one that seemed to give you trouble, this is 8.7. 7 seemed to be another happy one. Um, yeah, I can do that. Give me a second. Okay, so let's look at this one. So here the position of the object of circular motion is modeled by parametric equations. So here we have the two parametric equations. You're going to have x equal to something. In this case, it just gave me 8, 2 sine t, and y is equal to 8 cosine t. All right. And so here we're just going to plug in, a couple, and t's measured in seconds, right? And so here we're just going to plug in some values, right? So here if we plug in 0, I start here, right? When t equal to 0, I'm starting at, when t equal to 0, I get the point 0, 1, right? Or 0, 8, sorry, 8. When t equals pi over 2, I get the point 8, 0. When t equals pi, I get the point 0. Hold on, I'm starting in the wrong spot. I don't start here, do I? This is sine, this is cosine. So here, 8, 0. Here, this is 0 minus 8. And then, t at like 3 pi over 2. So I'm just plugging in some values. And the reason I plug in some values is because it makes sense what to do. Um, minus 8, 0. Okay, so let's do this. And so where do I start? I start here, right? This is where I start. I'm starting right here. This is my first point. Then as I move forward, I'm going to here. 8, 0. And so it kind of goes like this. And then when I go to my next point, it's minus 8, 0. And then when I go to my next point, it's or 0 minus 8, and the next point here. And then it'll actually end up going back to here, right? And so here I have my parametric equation with my directions. So you can say how long it takes and how long it takes to do a, a single revolution. In this case, it takes 2 pi, right? Let's pretend we had some other number in here. Let's pretend we had, I don't know, 4 of sine of 2t and like y equals 4 sine of 2t. Let's just do another example real quick so you get used to this. And then we'll go through this here. So here when t equals 0, I'm at 0, 4. When t equals 0, 0. When t equals, in this case, pi over 4, because I double it, I'll be at 4, 0. When t equals pi over 2, I'm at 0 minus 4, and then t equals pi over, or 3 pi over 4, I'm at minus 4, 0, and then when t equals pi, I'm at 0, 4 again. And so I made one revolution. So here I'm starting here and I'm going around this way. And this here is 4, and this one, in this case, it was 8. And here, so which way am I going? Going clockwise. How long does it take? Well, in this case, it took 2 pi. In this case, it took pi, right? Depends on what you get. Suppose I double the speed. What would I do? Well, you just increase this, right? That's how fast we're going. So here, if I double the speed, so here, just say if I double the speed, it'd be sine of 4t, right? Because I'm just going twice as fast. So everywhere I see a t, plug in 2t. And then, yeah, and then rectangular coordinates. Yeah, you have a circle. These are circles, radius 8 and radius 4. I assume you know how to make, define this. And so here, these end up being circles. You don't have to do anything fancy. I mean, you could, right? But it's not necessary. You just write the equation of a circle. So this is x squared plus y squared equals 4 squared. I mean, that's it, right? I mean, technically here, if I have, technically you can do the same thing we did before, where you have sine of theta, or you have sine squared x plus cosine squared x is equal to 1. And then here you just you set x equal to, in this case, 2t. And so it doesn't really matter if I have 2t here. That still equals to 1. I mean, technically that's how you do it, but since these are circles, you just make them circles. Someone had a question, what happens if I have something else here? Well, it's fine, it doesn't matter. Let's pretend I have x equals 5 sine minus, I don't know, 7. And y equals, I don't know, 6 cosine t minus 4. Well, all you do is the same thing we do here, is we have x minus 7 divided by 5 equals sine of t. And then here I have 6, or y minus, in this case, this would be a plus 4 over 6 equals cosine of t. And so here you'll have x plus 7 over 8 squared, just plugging it into there, plus y plus 4 over 6 squared. And then here you have one that's been shifted both horizontally and vertically. So the same thing for that. That should be able to get you through these two trouble problems. Do you have anything else that would the sine and cosine don't remember, if, as long as they still have the same as long as they have the same input. So even if I did put like a 4t here and a 4t here, as long as these are the same, you can still use this equation. Okay, you can still use this equation. Okay. Yeah. All right. Any of the other ones that give you real trouble on this exam? Yes, no, maybe. No, at least not for me. One last box. Oh, find the. Oh, for number 7, find the polar equation. Well, the polar equation is for a circle. And so since these are circles, this is just r equals 8. And then this is just r equals 4. That's a polar equation for a circle. Okay. Not for you. The only other ones that seem to be giving some people some trouble was 9. Um, clear out some space. Oops. Let's do 9 real quick. 9 seems to be a real troublesome one where you had -5, 1 minus I. Mhm. All right, so let's go ahead and kind of crunch through this. So here, um, so let's go ahead and fill in the negative sign. So -1 plus I, and then we'll leave the 5 out just for fun's these. And the reason I want to do that is because here, oh, we can put the 5 in. Let's just put it all in. So this is -5 plus 5I. Okay. And so what I would do is just quickly graph it real quick. So here we're at 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. And so what's this angle right here? I mean, we could solve for it, but it's not really necessary. What's So here, this is pi over 4. We know this, right? Because this is, since these are the same. And so we know this to be 3 pi over 4. So this is 3 pi over 4. So that's our angle. And then what's this length right here? Well, here we just take -5 squared plus 5 squared. Oops, squared, take the square root, and I get 2 square root 5. And so in this case, I'm getting 5 square root 2 times cosine or angle here, but 3 pi over 4 plus I sine 3 pi over 4. Okay. Um, all right. Someone wants me to do the 1 over z1 again. All right, I'm just going to use this one. So let's pretend this is our z1. I'm just going to use this one to explain that. So we have 1 over z1. And so just assume, so what we have here is, so what do we do here? And here we just leave this is a really simple, but so if we had, hold on, if we had z1 over z2, this is equal to z1 over z2, the magnitudes, right, of cosine of the argument of z1 minus the argument of z2, right, plus I sine. Okay, so now if we have it this way, it would just be 1 over the magnitude of z1 plus cosine of, and the argument for 1 is 0, right? The argument for 1 is 0 because this is a polar coordinate. is 1 cosine of 0 plus I sine 0, right? That's it in polar form, technically, right? So this is in complex number in polar form would be 1 cosine 0, I sine 0. So here I have 0 minus um, z, zeta 1 plus I cosine, or I sine, sorry, I sine 0 minus theta 2. And so for our case, if we let this to be z1, I'll have 1 over z1 equal to 1 over the square root of 5 square root of 2 cosine of minus 3 pi over 4 plus I sine 3 pi minus 3 pi over 4. Okay. And so if you just do 1 over that with no other thing, you just put your argument, divide by your argument, and just negate whatever you or divide by your magnitude and negate your argument or I think I said theta for you guys most time. I know it is arguments because of complex stuff, but same concept, same thing. All right.